One, we were at the logistics growth functions, and we had, that was it to finish up, right? So your logistics growth function says let A, B, C, and K be positive constants with B less than 1. A logistics function, in X is a function that can be written in the form f of x equals c over 1 plus a b to the x. Or f of x equals c over 1 plus a e to the negative kx. So the key there, a, b, and k are all just a constant, just a number. So your only variable in there would be the x. Where c is the limit to growth or carrying capacity. Let me try that again. Carrying capacity. There we go. So when I think about something that has a carrying capacity, I think of like an island can only support so many people. A pond can only support so many fish. And so that carrying capacity is always going to be what's in the numerator of a logistics function. So the maximum that it could be. Does that make sense? Okay. This is something that you're going to have to make sure you know. Okay? The graph of the function, find the y-intercept and the horizontal asymptotes. So the y-intercept is where x is 0. Do you agree? So we're finding f of 0. Meaning we'd have 18 over 1 plus 5 times 0.2 to the 0 power. Well, anything to the 0 power is just, so we have 1 plus 5 times 1, which would give us 18 over, so f of 0 is 3, correct? 18 divided by 6. Does that make sense? So thinking of horizontal asymptotes, the carrying capacity would give us a horizontal asymptote, right? Because it can never be above that carrying capacity. Is that true? So y equals 18, we know has to be one of the horizontal asymptotes. But what else would be true? If we put negative numbers in for x, are we going to get a negative y value? No, because that is an exponential function, right? And exponential functions never go below 0, correct? And so your other asymptote would have to be y equals 0. So we have a horizontal asymptote, and we know that this function is going to have to be between where y is 0 and y is 18, yes? And I know I need to cross at 3, so I'm going to go by 3s. So up here, this would be y equals 18. And I know my y-intercept is the point 0, 3. Correct? So the rest of that, what do you think it will look like? We're going to graph it on our calculator here in a second, but what do you think that would look like? As we put negatives in, what's going to happen to this? If you were to put -1 in, it'd be 1 over 0.2, right? Which means 1 over 2/10, or 1 over 1/5, which would be 5. Times 5 is 25, plus 1 is 26, so 18 over 26. If you plug in -2, then it's 1 over, it'd basically be 1 over 1/25, correct? And then you multiply 25 times this, you're going to get 625 plus 1. So 8 over 600 and something is going to be smaller yet, isn't it? So as we're going to the left, this is going to be getting closer and closer to, and as we're going to the right, what do you think is going to happen? It's going to increase, right? And so knowing that, we know this is going to get closer and closer here, and this is going to get closer and closer here, so we know it's got to have some sort of point of inflection in there, don't we? So if you look at this as a graph, we know in a standard window we're not going to be able to see the top because we said it was between 0 and 18, right? So I'd have to go to my window and adjust that. And I'm adjusting which value, X or Y? Y. So my Y's are between 0 and 18, fair? And so you can see what's happening here. This is approaching this horizontal asymptote, just like what we said, and then here, this is going to be approaching that other horizontal asymptote, correct? And then there was some point of inflection in here. Remember, point of inflection is where it changes from concave up to concave down, or vice versa. Questions on that? All right, let's look at example 8. It says an exponential function of the form g of x equals a times b to the negative x is shown in the table below. Use the table to answer the following questions. Well, if we look at this, we know that as our x's are getting smaller and smaller and smaller, what's the function value doing? Getting the function value as we go to the left, what's happening? Those are getting way bigger, aren't they? As your x's get smaller and smaller and smaller, what do you think this y value is going towards?
2.
Right? This was 2.47, this was 3, and then it was down to 2.47, and now it's down to 2, right? And so if you kept going, it would likely get like 2.00001 or whatever, right? So it's getting closer to 2, yes? So what that tells me graphically is that if it's getting closer and closer to 2, we would have something that looks like this. And if as I go left, these are getting bigger, and as I go right, it's getting closer and closer to 2, it's going to have to look something like this, correct? Which, remember, a normal exponential function looks like this, doesn't it? Well, that negative there has reflected it, hadn't it? Yeah? So A says, describe the end behavior. Well, remember, with end behavior, we're talking about the limit as x approaches negative infinity of the function. In this case, our function is g of x. And the limit as x approaches positive infinity of the function. Yes? Questions? So as it goes to the left, we said that function value is getting bigger and bigger and bigger, which would be going to infinity, correct? And as we go to the right, we said that function value is getting closer and closer and closer to 2. So what does that tell me about my horizontal asymptote? It's at y equals 2. Remember, it is an equation of a line. If you just put 2 there, it's not correct. Do we understand that? All right, what conclusion can be made about the value of A? What do we know about A? So this right here. We don't know what it is, but we do know something about it. Think of your transformations. If A was negative, what would happen? Yeah, it'd be flipped upside down, wouldn't it? So if A was less than 0, it would have been flipped upside down. Yeah? From this one. From this one, if it'd be flipped upside down, it would have looked like this, yes? So we know that A has to be greater than 0 since g of x is always greater than 2, right? It's bigger than 2. What about C? What does it tell us about the C? Thinking of your transformations, what is that C representing? Which transformation? Yeah, right? That's that vertical transformation, isn't it? Going up 2. So what's the value of C? 2, right? Because our normal has a horizontal asymptote at 0, yes? And so because this one has a horizontal asymptote of 2, C has to equal 2 since that y equals 2 is the horizontal asymptote. Questions there? So that's all about exponential functions, right? And the logistic function.